The immune system. We couldn't survive without it. It protects us from infection, harmful substances, and malignant cell changes. But it can also be vulnerable and pose a threat to our health.
The immune system is a powerful organ with some mighty weapons. When these weapons are used to fight a pathogen, it's great. But if they're turned on a healthy body, it's bad.
How does this complex system work? What causes it to go wrong? What factors influence it?
The immune systems of men and women are different.
It's generally agreed that infants are more vulnerable to infections. However, that's not the whole story.
The intestine is key. It's where most external substances enter the body, so we need a strong immune system there.
Especially in recent years, partly due to COVID-19, medical professionals around the world have gained new insights into the immune system. This has given rise to promising research. Could our immune systems be capable of much more than we thought?
The immune system is mainly seen as a mechanism protecting us from microbes, but it's actually a system that protects us from all kinds of health threats, especially cancer.
Whether someone has a strong or a weak immune system depends on many factors. It's a defense mechanism that's hard to pin down because it doesn't have a fixed location in the body.
The immune system is one of our largest organs, distributed throughout the body. If I asked you to point to it, you couldn't. It's everywhere. Immune system cells originate in a few places: the bone marrow, the thymus gland, and the lymph nodes. Our intestines host 70% of all immune cells, but the rest are mobile and constantly moving around the body.
Key components of our immune system are present right at birth, but much of it develops later. That's because a baby's environment changes very suddenly when it's born. Hamburg, Germany. We've come to the University Medical Center Eppendorf. It's long been debated whether a natural birth is more beneficial for a child's immune system than a cesarean. Most research suggests it is. Pediatrician Robin Kobbe specializes in infectious diseases and has spent years studying children's immune systems.
There's
definitely a difference when a baby is born via caesarean section and abruptly removed from a sterile environment. These babies are predominantly colonized with microbes from around the mother's mouth and skin. With a natural birth, vaginal and intestinal flora are more likely to take hold. And that mixture is very important for the first weeks of a child's life. So, for example, babies born by C-section are generally a little more susceptible to infections and allergies.
Even more important is how a child grows up in the first few years. Breastfed children are better equipped to fight off germs than children who were fed formula. Above all, young children need plenty of exposure to their environment.
There's a hypothesis that children who grow up in very clean environments are more likely to develop allergies later. Children put everything in their mouths, and that's important. They're encountering lots of microorganisms.
There's actually no evidence that you can prevent most infections by shielding children very carefully.
The COVID pandemic was a big exception. Children and adults experienced high levels of shielding due to the use of face masks, hand sanitizer, and social distancing. Once those measures ceased, children's hospitals filled up fast.
During
the pandemic, these measures were very important to keep the number of infections under control. In some cases, it was probably excessive. It probably meant that 1 or 2 annual cohorts of kids bypassed their initial exposure to respiratory illnesses. Not just COVID, but also RSV, the flu, and rhinoviruses. When the masks came off, 3 cohorts of kids had their first exposure all at once, which drove up the number of cases.
Viruses, bacteria, and parasites lurk everywhere and can pose a threat to our health. Once they breach the first protective barrier, such as the skin in the case of a cut, or the mucous membranes when breathing, the body's first line of defense is activated, the innate immune system. Our immune systems consist of 2 key pillars that work together. One is innate, and one is adaptive or acquired. The innate immune system protects us from birth. It reacts to pathogens promptly, using its arsenal of weapons. These include macrophages, neutrophils, and natural killer cells that fight off the intruders.
The advantage of the innate immune system is that it's activated very early in an illness. It reacts within minutes or hours.
The innate immune system recognizes threats with no prior training. It spots that something is wrong in the body. It sounds the alarm, activating innate immune cells to attack an enemy, like the COVID virus, for example.
If the enemy is too strong, like in the case of flu, the innate immune system is overwhelmed, and the body sounds the alarm.
That's when the acquired part of our immune system kicks in. It has bigger, more potent weapons that can fight an infection in a more targeted and effective way.
The acquired immune system has another advantage that's handy when pathogens return a second or third time.
This system is able to remember past threats, and it's this system that is activated by vaccination.
The adaptive immune system relies on T cells and B cells. Both are crucial for fighting diseases and are produced in the bone marrow. T cells migrate to the thymus, where they're trained in fighting pathogens.
Humans can't live without T cells. The risk of serious infections increases massively without them. We're born with a certain level of protection through antibodies from our mothers, but these only last for the first 3 to 6 months, then gradually decrease. After that, very serious infections develop in children who have no T cells.
As a result, several countries, including Germany, have added T-cell screening to their blood tests for newborns. The screenings test whether a baby carries a sufficient number of T-cells or has immune deficiencies. It's rare that babies are born with no T-cells at all. Alongside T cells, another type of immune cell plays a key role in the body's adaptive defense system. They're known as B cells. When a pathogen attacks, these B cells spring into action. They transform into plasma cells, which then release antibodies to target enemy antigens, like the coronavirus. These antibodies mark the pathogens and destroy them with the help of other immune cells.
Since the COVID pandemic, people have become used to hearing about antibodies. Unlike T cells that fight viruses that are already inside the cell, these antibodies attach themselves to the outside of the virus.
In this respect, antibodies are very important. They're produced naturally following exposure to antigens or through vaccination.
Just how important B cells and antibodies are becomes clear when people can't produce them, due to a genetic defect. This is known as Bruton's disease.
Like kids with T-cell defects, these children develop serious infections, although not quite as serious. It happens after the mother's antibodies decrease at around 6 to 9 months.
That was the case with 8-year-old Eliel. For the first 6 months after birth, everything was fine. But then his mother discovered abscesses on his neck and groin, prompting surgery. A blood test showed Eliel had no B cells. Because Eliel can't produce antibodies himself, he'll need regular infusions of them for the rest of his life. These days, that can happen at home once a month. Eliel needs to go to the hospital for occasional checkups, but if he continues to take the antibodies, he can lead a normal life, one filled with his hobbies, playing football, and doing judo. Most people have both B and T cells, but even their immune systems are often overwhelmed, especially when an unknown, highly aggressive pathogen comes along.
COVID-19 was a new type of virus. None of us had seen it before. For each patient, it was the first time their immune system had to deal with this pathogen.
The biggest risk factor for COVID was age. Older people were more at risk. Pre-existing conditions also increased risk, especially for those who were immune compromised or had chronic inflammatory diseases.
The World Health Organization has logged over 7 million deaths since the start of the pandemic. The real figure is thought to be between 2 and 4 times higher.
People were dying of COVID not because the virus kept multiplying in their bodies. They were dying from a severe inflammatory response. When autopsies were carried out, it was often impossible to detect any trace of the virus. Patients were dying of excessive inflammation that caused fatal damage to their organs.
The city of New York was especially hit hard by COVID-19, experiencing a high death toll. Overcrowded hospitals and emergency measures lasting almost 2 years. Like elsewhere, many children contracted the virus. But it was the older population, or those with pre-existing conditions, who tended to be seriously ill. Why was that? One researcher looking for the answer is Donna Farber from New York's Columbia University. She has spent years studying children's immune systems.
So it's generally agreed that infants are more vulnerable to infections. They haven't seen viruses, and they don't have their own memory response. However, that's not the whole story. In fact, infants see many new pathogens. They're introduced to everything, when they're born. And so they need to have an immune response that's going to be strong to fight off all of these new pathogens. So when you start looking deeper into the immune system of children, you realize that their immune cells are actually quite functional. And in fact, they're even more functional than the same kind of immune cell in adults.
She suspected that it was this strong immune response that protected children during the pandemic, which saw only relatively few children becoming seriously ill. But Donna Farber wanted scientific proof, focusing her research on T cells, first in mice and later in children. She found that children have many more so-called naive T cells, which are very effective at fighting new viruses. This gave them an advantage when they encountered COVID-19.
What we found in mouse models, and also a bit in some human studies, is that T cells in infants are actually more easily activated and respond to even lower doses of a virus compared to these new T cells in adults. What happens is when babies are born, all the T cells they have are naive, pretty much all. Whereas adults, practically most of the T cells we have are memory, because we have seen antigens, and every time we see a pathogen or an antigen, we develop memory. How effective our immune systems are doesn't just depend on our age.
what other factors govern our immune response? Paris, home, among other things, to the Pasteur Institute. Named after Louis Pasteur, considered the pioneer of modern immunology. Geneticist Luis Quintana Murci is an immune system expert. He led a study involving 1,000 people from France that examined the factors that influence the body's defense systems.
Nous avons recruté 1000 individus sains de 20 ans.
We recruited 1,000 healthy individuals, aged 20 to 70, half of them men, half of them women. All of them were asked to complete a very detailed questionnaire on a range of factors that could potentially influence the immune system, including information about their vaccination history and very precise details about their diet.
Le système immunitaire. Et pour chaque individu,
a blood sample was taken from each person and then stimulated with various pathogens. This allowed us to assess their immune response to certain bacteria or viruses.
After several years of research, the results were clear.
The 5 factors that most affect the immune cells in our blood are genetics, age, sex, whether we smoke, and whether we're infected with the cytomegalovirus. This common virus is present in many of us. Although chronic, it rarely causes problems in healthy people, and you're unlikely to have any symptoms.
The pathogen, a member of the herpes family, sometimes causes flu-like symptoms. In Europe, around half the population is infected with the virus, which is transmitted through direct contact with bodily fluids.
Once you have cytomegalovirus, or CMV, your immune system changes. Certain cells are only found in individuals who are CMV positive. Immunologists are still unsure what this means. All we know is that we find these cells. They seem to have certain effects on some people, but we still haven't been able to quantify that. But we do know CMV can be a problem when doing transplants.
The Pasteur Institute study has shown that men and women have slightly different immune systems, a finding backed up by other studies too.
From an epidemiological perspective, we know that men are generally more susceptible to infectious diseases, and women are generally more prone to autoimmune or inflammatory diseases.
But whether you're a man or a woman, or whether your immune system is strong or weak, the cells fighting off invaders aren't found only in your blood.
Most of our immune cells are not circulating in blood. They're in tissues. They're in lymphoid organs, like lymph nodes, spleen, and bone marrow, but also throughout the body. So we have a lot of immune cells in the lung, in the intestines, and in the skin. So it's all of these, what we call barrier sites. And so all of these barrier sites have huge immune populations. It's almost like they have a local immune militia.
Like athletes and musicians, these immune cells need to undergo training to learn how to combat pathogens effectively. And for that, they need a healthy microbiome. The microbiome refers to the sum total of useful bacteria, viruses, and fungi that live in and on our bodies, plus their genes. They live on the skin, in the lungs, and the intestine. Bacteria living in the intestine are tolerated by our immune systems. They train the immune system to distinguish between harmful and non-harmful bacteria. Gérard Hébert is an immunologist at the Pasteur Institute. For over 20 years, he's studied the link between people's immune system and the diversity of their microbiome.
There's a strong link between the microbiome and the immune system. They're constantly in dialogue with each other. When we're still in our mother's womb, everything is sterile. But when we're born, we encounter our mother's microbes. And this microbial contact is very important for the development of the immune system. If we don't start building this microbiome at birth, the immune system will develop differently, sometimes less effectively. Someone who was born in a bubble where there are no bacteria will overreact as soon as they encounter a few bacteria.
The diversity of the microbiome plays a key role in a healthy immune system. This includes having a wide array of gut bacteria.
The intestine houses 300 or 400 types of bacteria. That's important because the bacteria play different roles, digesting food, producing vitamins, or fighting off pathogens.
Alors l'intestin, c'est comme une société, un quartier, un écosystème.
The gut is like a community, a neighborhood or an ecosystem. Lots of people do different but important jobs, and there are lots of different bacteria too. There's a professor, a bricklayer, a hospital worker, and we need all these people, all these bacteria, to make sure everything runs smoothly. It all goes well until one day an element of the microbiome says, "I've had enough. I want twice as much as him. I'm going to get rid of him," and he starts taking over. That's when the immune system kicks in and says, "Hang on, that's not good. We've got a problem." It identifies this element that's becoming invasive and neutralizes it to prevent infection. That's the immune system's job, not just to check that everything's okay, but also to recognize overstimulation and to say, "Calm down," or to eliminate the problem. What we see with people with inflammatory disease or abdominal issues is a decrease in microbial diversity.
If the first years of life are so important for our microbiome and immune system, can we still take steps to influence them later?
There are parallels between the microbiome and our speech. In Germany, children learn to pronounce the ich sound from a young age. For French people, it's much harder to say because they didn't learn it as a child. Although a microbiome that wasn't established in childhood can still be corrected, it's much more difficult.
Back to Hamburg. Viola Andresen is a doctor for internal medicine and nutrition at Hamburg's Jewish Hospital. She sees many patients with a poor microbiome and intestinal problems. They're often caused by illnesses linked to the immune system.
The intestine is key because that's where most external substances enter the body. So we need a particularly strong immune system there. Our body's entire immune system is actually controlled from within the gut. Chemical messengers are released and circulated via the blood to the brain to trigger specific immune phenomena.
What's especially bad for gut health and therefore our immune system and entire body is the so-called visceral fat on the belly.
It's fat that sits around our vital organs. It thrives off a carb-rich diet that generates high insulin levels. Excessive insulin is what causes this fat to be deposited in these areas. The fat triggers inflammation, which means our immune system is active, and it has to act because the intestinal barrier is compromised, allowing more bacteria into the bloodstream, and these bacteria have to be fended off.
Many studies suggest that an impoverished microbiome is linked to a poor diet. So what should you eat or not eat for a healthy immune system? For one thing, avoid sugar.
And avoid highly processed food because it usually contains lots of additives. There's a whole body of evidence showing this can impair the microbiome long term. What you should definitely eat is vegetables, fiber. I think that's the be-all and end-all for doing a lot for your gut bacteria. Wild broccoli. Wild vegetables are much more nutritious than cultivated varieties. Broccoli is really healthy. It's packed with vitamin C and fiber, so it's ideal for the immune system. Legumes are especially good, beans, but also a lot of fruits like berries. They contain healthy pigments, especially the red berries, which have a positive impact on our immune system. Omega-3 fatty acids have anti-inflammatory properties. If you have an increased tendency to inflammation, for example, excess belly fat, it's best to opt for anti-inflammatory foods. Or if you have a diagnosed inflammatory condition or autoimmune disease, like rheumatoid arthritis, it's been proven to help.
In addition to a healthy diet and avoiding antibiotics when possible, it's well known that exercise is good for you. But how exactly does exercise affect our immune system? And how much of it is good for us? Since childhood, Carsten Krüger has always loved staying active. Now he's a researcher in sports science at Justus Liebig University in Gießen, Germany.
The immune system is at the core of my research because many processes that keep our bodies healthy or restore them to health are linked to the immune system, and lots of lifestyle diseases are linked to a dysfunction of the immune system.
One of his studies investigates how exercise influences the aging of the immune system. As we grow older, our natural defenses become weaker.
As we age, the immune system changes. We call it immune aging. It's completely normal. What's interesting is that we know that the speed of immune system aging depends on how active we are. How much you exercise determines whether your immune system ages faster or slower.
At his institute, Carsten Krüger tested 100 individuals over the age of 55 with no pre-existing conditions. One of them was Uwe Dombach.
I keep fit by cycling once a week 40 to 50 kilometers. I run for an hour and do karate once a week. Every day I do a 10-minute workout and stretching.
The 64-year-old is now completing various exercise tests and health checks at the institute to see if his routine is making a difference.
When I say go, you have 5 seconds to exert as much force as you can. Ready? Go. Go, go, go. Push, push, push. Okay, that was 174 Newton meters.
Nice and steady. I'll check your blood pressure again. Now it's getting tough. 160 over 80. Want to cool down?
Uwe Dombach has done well. That's important because with age, the balance of our immune cells changes, especially the T cells in the adaptive immune system.
These cells undergo significant changes with age and are also very sensitive to lifestyle factors. So people who keep themselves fit and healthy and eat a healthy diet maintain their T cell repertoire, keeping their T cells a little younger and more effective.
Next, Carsten Krüger heads off to the lab to analyze Uwe Dombach's T cells. How many of his T cells show signs of aging? Has his active lifestyle made a difference? The results are ready a few days later.
Your profile looks like that of someone 20 years younger. You still have a relatively high number of lymphocytes, which we call naive T cells. You don't have many aging T cells, which can be very damaging to blood vessels. And your inflammation levels are still quite low.
I've probably done a lot right. I do it to stay fit and healthy and hopefully continue living like this for a few more years.
And Uwe Dombach's is no isolated case. All test subjects who eat a healthy diet and exercise regularly have been found to have a relatively young immune system for their age. Exercising several times a week and eating a healthy diet both benefit your immune system, as do sufficient vitamin D and plenty of sleep. And cutting down on stress. It turns out stress is a much underestimated factor impacting our immune system, a connection now being researched extensively. We're back in New York. If you're looking for deep relaxation, don't go looking for it in the Big Apple. But how does constant stress affect your health? Cardiologist Wolfram Poller, originally from Germany, did a groundbreaking study on the immune system and stress at the Icahn School of Medicine in Manhattan.
As a cardiologist, I'm very interested in how we live our daily lives, how stressed we are, what mechanisms we have for reducing stress, and how that affects cardiovascular disease.
To find answers to these questions, he and his team conducted a study.
We first asked, how does acute stress affect the immune system? To find out, we exposed mice to various stress factors. We then analyzed the immune cells in the blood of the stressed mice and in the control group of relaxed mice. We compared the two groups to see how many B cells, T cells, monocytes, and neutrophils they each had.
The scientists were especially interested in finding out what happens to the immune cells of mice that are stressed and infected with COVID or flu. The results?
We saw that acute stress caused a sharp rise in the number of neutrophils in the blood. Neutrophil granulocytes are cells of the innate immune system, the first line of defense against bacteria. On the other hand, we observed a big drop in B and T lymphocytes, which are part of the adaptive immune system.
Wolfram Poller noticed that the adaptive immune cells actually retreated into the bone marrow. That meant the mice couldn't mount a strong immune response to the invading virus.
When the flu or COVID infection coincided with the period of pronounced stress, the course of the disease was worse. And in mice, at least, that led to an increased mortality rate. So acute stress, especially when it occurs over several days and in an intense form, is definitely bad for fighting viral infections because it prevents a strong adaptive immune response.
Wolfram Poller continued his research on people by using virtual reality to create different moods.
I'd like to record it. Is it good? Yep. Is it tight enough?
Yep. Maybe a little tighter.
He wanted to find out how both stress and relaxation influence our immune systems and the effectiveness of vaccines.
For 30 minutes, we exposed healthy individuals to a virtual reality that is either relaxing or stressful.
The study yielded valuable insights.
Acute stress in an emergency prepares the body for a fight or flight response. Blood pressure, heart rate, respiratory rate, sweat production. All systems are activated to enable the fastest response. All the body's strength and reserves are made available to increase the chances of survival.
In an emergency, it's ideal. But if the stress becomes chronic, it has a negative impact on the immune system.
High stress levels definitely weaken the immune system, especially the adaptive immune system, in fighting viral infection or developing a strong immune response to vaccination. So doctors need to consider and treat stress as a factor in the cause and development of illness.
But a balanced diet and stress reduction can only go so far in warding off certain conditions. And even our immune systems can get it wrong and begin attacking the body. If the immune system mistakes the body's own cells for something foreign, it begins to destroy them. The immune system may attack the skin in the form of psoriasis, the joints in the form of rheumatoid arthritis, or the cells of the pancreas in the form of type 1 diabetes. These are all autoimmune diseases.
When it comes to autoimmune diseases, there are two main causes which must come together. One is a genetic predisposition inherited from our parents. The other is what we call environmental factors. These could be infections or pollutants that I'm exposed to. It could be the microbiome. It could be chronic infections I may have. Autoimmune diseases are thought to be on the rise. Levels are currently around 10%. It won't be genetic changes driving this trend. It's not our genes that are changing in such a short amount of time. It's the environmental factors.
There are around 80 known autoimmune diseases. Statistically, they affect women more often than men.
When you quantify it, women have stronger immune systems than men. But when it comes to autoimmune diseases, a stronger immune system is a disadvantage. There are certain autoimmune conditions where women are many times more susceptible than men. Lupus is one, but also rheumatoid arthritis and other conditions. It might be linked to sex hormones. It might come down to genetics. Women have 2 X chromosomes, and some genes that are central to the immune system sit on these X chromosomes. Women have twice the dose, while men only have 1 X chromosome.
Much remains unknown, and there's still no universal cure for lupus or other autoimmune diseases. But medical science is slowly making progress. Research into the immune system is focused not only on autoimmune conditions, but on other serious illnesses too, especially cancer.
When you administer chemotherapy or radiotherapy, you try very hard to target the tumor, but you never really manage to isolate the diseased cells precisely. The dream of cancer immunologists like me is to use precisely these attributes of the immune system to develop targeted therapies, where the immune system recognizes cancer cells and can kill them, while at the same time preserving the rest of the organ. The other extraordinary feature of the immune system is its memory. It will be able to remember and prevent relapses because cancer patients die from relapses, rarely from the primary tumor. You die from what's known as a relapse.
We're in Heidelberg, home to Germany's National Center for Tumor Diseases, one of the world's leading institutions for cancer treatment. For years, the center has used and developed immunotherapies. Dirk Jäger, a managing director at NCT, is spearheading new research.
The immune system prevents many tumors from developing in the first place. In fact, hundreds of tumor cells are created in our bodies every day. But our immune systems are very effective at recognizing these cells and destroying them.
In the case of cancer, the immune system is no longer able to recognize these cells. It needs a helping hand, a boost, and a cue to fight the enemy.
Many immunotherapy procedures are now focused on strengthening the immune system's defense mechanisms to make them more effective again at controlling or eradicating tumors.
All over the world, scientists like Dirk Jäger are working on new immunotherapies for cancer. The T cells of the adaptive immune system play a crucial role.
We believe that T cells, those specialized subunits of white blood cells, are especially good at recognizing and destroying tumor cells. Immunotherapy aims to strengthen or increase this T cell response, or to make cellular immune responses more effective using procedures that aim to modify or reprogram the T cells.
A study is currently underway that aims to use a multi-stage process to get T cells to fight malignant tumors. The first step in this immunotherapy is a therapeutic individualized cancer vaccination.
We want to use a vaccine to induce an immune response that can fight the tumors. But with cancer, the process is much more complex than it is with infectious diseases, like a virus. That's because we're dealing with a very heterogeneous disease, a mishmash of tumor cells that are not all identical.
Elements of selected tumor cells are analyzed and modified to create a personalized cancer vaccine, which is then administered to the patient. This peptide vaccine prompts the immune system to activate and respond appropriately when it encounters these cancer cells. As a result, the malignant cells are attacked. But to ensure these tumor cells really are eliminated by the immune system, the researchers go one step further.
We then isolate the patient's immune response by taking a biopsy from the vaccination site. We then multiply those cells in this machine. We attempt to massively multiply the patient's immune response inside this device. We then administer that back to the patient via an infusion.
Dirk Jaeger has already used this experimental therapy on 4 patients. All over the world, research on immune therapies is continuing, and some are already being used to treat patients.
I think immunotherapy will become an integral part of cancer treatment for patients everywhere. But there's still a lot to do. We're only at the very beginning.
The human immune system is receiving more attention from researchers than ever before, and not just to develop cancer treatments.
We can vaccinate people. We may even beat cancer through immunity one day, but we can't yet suppress excessive immune responses in a targeted way. We still have lots to learn about how to specifically switch off those responses. I see a lot of potential for maybe curing autoimmune diseases and allergies too.
Scientists agree that while our immune system can protect us against disease, it is also vulnerable and fragile. The goal must be to strengthen our body's defense mechanism while keeping it in balance. If it's too weak, it can't protect us. If it's too strong, it can do more harm than good.